So hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. Today we are going to take the topic transpose and adjoint of a matrix in the course Computational Mathematics. So first of all we have to know what is matrix. Matrix is nothing but arrangement of rows and columns. So the matrix can be transposed into A transpose. That is, we can interchange rows in columns. So first of all we can say what is meant by row, column and dimension change. The transpose of a matrix is denoted by A transpose and it can be transformed into a columns. If it is in the form of a column means we can transform into rows. Then dimension change means the matrix can be m row n column means it can be transposed into n rows n m column. So this is the main dimension change occurs in the transpose of a matrix, and also some of the properties behind the transpose of a matrix. So A transpose, the whole transpose, you will get A, and as well as A plus B the whole transpose equal to A transpose plus B transpose. This is the addition property, and you have a multiplication property also. AB the whole transpose equal to B transpose A transpose, and some of the applications are available in the transpose of a matrix. That is, it should be a symmetric, orthogonal, and as well as adjoint calculation can be done in the applications also. So what is meant by orthogonality? That is, A transpose into A is equal to identity matrix. This is the orthogonal for the transpose of a matrix. Then we can move on to the adjoint of a matrix. So adjoint of a matrix is normally can be accepted in the linear algebra, and also we can find the inverse of a matrix using the adjoint of a matrix. So the inverse of a matrix formula is A inverse equal to 1 by modulus of A into adjoint of A. For the inverse of a matrix we have to know what is meant by adjoint of A. So adjoint of A is denoted by adj. So for the adjoint of matrix, first we have to transpose the cofactor of a matrix. Then after finding the cofactor of matrix, that is, the formula for the cofactor is minus 1 whole to the power of I plus j, which will be multiplied by the minor matrix, that is mij. So first we have to transpose the matrix, then we have to find the cofactor, and we have to check whether the square matrix only. The adjoint is only defined for the square matrix, unlike the transpose which applies to any matrix. And finally, after finding the adjoint of matrix and cofactor and minor of the problem, then we can apply in the relationship of inverse, that is A inverse equal to adjoint of A by determinant of A. But we have to check the determinant of A should not equal to 0. That the concept we have to check. If the determinant of A is equal to 0 means that inverse does not exist. So this is the rule we have to follow in the adjoint of matrix. So how to find adjoint of matrix? Just first compute the minor matrix and create a minor matrix mij by deleting the rows and columns. So if you want to find the value for 1 means we have to delete the row of 1 and as well as column, and remaining values we have to take. So that is considered as a minor of the matrix. Then we have to give the sign for the value, that is plus, minus, minus, plus. Alternately we have to give the sign. So that is represented as cofactor of the matrix. Then we have, after finding the cofactor of matrix, we have to arrange the cofactor matrix in a certain rows, and you will get a new matrix, that is known as a cofactor matrix. Finally, after finding the cofactor matrix, you can transpose the matrix. So this is the definition to find the adjoint of A. So first of all, you have to compute the minor matrix, then you have to calculate the cofactor, that is giving the sign for the matrix. Then arranging, after finding the new values, you have to enter the matrix. So this matrix have a sign. Then finally you can transpose the matrix. Okay. So next example for the transpose and adjoint matrix. For example, if it is a 2 by 2 matrix, means they have given 1 minus 1 1 4. The transpose of a matrix is nothing but you have to transpose the matrix. That is either A transpose is nothing but 1 1 minus 2 4. Then cofactor is 4. C12 is 1, C21 is 2, C22 is 1. Then you can arrange in the form of a matrix, that is 4 minus 1 minus 2 1. Then transpose the matrix. Transpose is nothing but row should be transformed to the column. Then you can find the formula is first calculate 9 minor matrix, then 9 cofactor with alternating sign, then construct a 3 by 3 cofactor matrix. Finally, transpose the cofactor matrix to get the adjoint. So what is the difference between the transpose and adjoint matrix is given below. The straightforward operations that swaps rows and columns of any matrix. In adjoint, the signs of the square matrix can be calculated by giving the alternate sign. So these are the concepts involved in transpose and adjoint of a matrix. An overall summary is given. The transpose is nothing but a simple rearrangement, while the adjoint is nothing but finding the cofactor and calculation. So using the repeated calculation, we can solve adjoint of A, and it is applied for the inverse also. So the adjoint is crucial for deriving the inverse of a matrix also. But we have to check whether the modulus of value should not equal to 0. So the strength and skills is nothing but it helps us to understand the transpose and as well as the adjoint of the matrix, and it enhance the linear algebra proficiency. So thank you for understanding this concept. So in this concept we have discussed the transpose and adjoint of matrix. Thank you, students.